the energy that gave us life will become unbearable.
Let's go! Come on!
This is Earth's future. Our sun will die. But how long do we have? When will it run out of fuel? And what will that mean for us? What exactly will happen on Earth when the sun approaches the end of its life? Welcome to New Nature. Over the past 3 months, we've worked with leading scientists, astrophotographers, and VFX artists to reveal the sun as you've never seen it before. This is a journey through groundbreaking science, breathtaking visuals, and the incredible story of our star. From the start to its very end. The sun powers life, shapes climates, and drives evolution. Understanding its story helps us understand our own. But to know the sun's future, we need to rewind and go back to its beginnings. This is our Milky Way galaxy. 4.6 billion years ago, before our sun existed, the galaxy was a chaotic mix of gas and dust. Somewhere in space, suspended by gravity in one of the Milky Way's spiral arms, was a cold, swirling cloud of gas and dust. Over time, gravity pulled this gas and dust together, causing the cloud's core to heat up and become denser and denser. As more and more material got pulled in, pressure and temperature increased drastically, until hydrogen atoms overcome their natural repulsion and fuse into helium, releasing a huge amount of energy. This process, called nuclear fusion, ignited the sun and made it shine. In a way, gravity turned chaos into light. But how do we know this? What you're looking at here is StarForge, a simulation that shows how clouds of gas collapse to form stars. It condenses billions of years of star formation into a few moments. It's a beautiful dance of gas and dust coming together to form stars like ours. It set the perfect conditions for Earth to evolve life. We see and feel the sun every day. But have you ever stopped to wonder, what does it actually look like up close if it wasn't so bright? This here might look like the sun you know. But what you're actually seeing is something hidden from the human eye. Scientists use ultraviolet imaging to reveal electromagnetic activity you could never see otherwise. So, if this is not the real view of the sun, then what would it actually look like up close to the naked eye, if you could look at it? Things aren't always as they seem. Familiarity can be deceiving, and reality is often more complex. The same goes for life and relationships. Sometimes a new perspective makes all the difference. Talking to a therapist can help you find real answers. That's where BetterHelp, our paid partner, comes in. BetterHelp is an online therapy service that connects you with a credentialed therapist who can help you work through life's tough questions. From relationships to self-doubts and everything in between. It's simple to get started. Complete a quick questionnaire, and you'll be matched with a therapist in as little as a couple of days. And here's what's great. These therapists are trained to help with the deep stuff, the things you might be afraid to say out loud. No judgment, just understanding and real guidance. And if it's not the right fit, you can switch at any time at no extra cost. Your therapist is available through video call, phone, or messaging, all from the comfort of your home. With over 7,000 reviews and a 4.5-star rating on Trustpilot, it's a platform you can trust. I know that voice in your head saying, I should be able to figure this out on my own. The strongest people aren't the ones who tough it out alone. They're the ones brave enough to reach out when they know they deserve better. You're not taking the easy way out. You're taking the first step toward the types of relationships you've always wanted. If you're ready to gain clarity and get real answers, scan this QR code, visit betterhelp.com/newnature, or click the link in the description to get 10% off your first month of therapy. Sometimes, what we think we understand is just the surface of something far more complex. The same is true for the sun. If you could strip away its glare and see it as it truly is, you'd uncover something far more intricate, more alive, and more powerful than you ever imagined. The sun is not just a giant ball of fire. It's a complex structure made up of many layers, each playing a unique role in how it behaves and sustains life on Earth. Before we can explore the sun's surface, we need to understand these layers and their interactions. The corona, the sun's outermost layer, also referred to as the sun's atmosphere, is a vast halo of superheated plasma. Most of the time, it's invisible to us. But during a total solar eclipse, the corona becomes visible as a glowing halo around the sun. Outside of this rare event, scientists rely on special wavelengths like ultraviolet and X-rays to observe it. These wavelengths reveal incredible features like loops of charged particles shaped by magnetic fields, twisting far into space. The corona is also where solar flares can be visible, bursts of energy that can extend millions of miles and impact the entire solar system. To study the corona up close, NASA launched the Parker Solar Probe in 2018. This groundbreaking mission just flew closer to the sun than ever before, essentially touching the sun.
So this mission is so significant because it's actually going where we've wanted to go for decades, to understand our star.
This is Dr. Nicola Fox, Associate Administrator for NASA's Science Mission Directorate.
Our sun, we take it for granted, it's in the sky every day, but it's actually a living, breathing, kind of very, very active star. We have a connection with that star, but we don't really totally understand how it works. And the only way we can understand is to send this daring mission into the searing heat just to get us the data that we've waited for decades and decades.
During its flyby in December 2024, it also became the fastest object ever made by humans, reaching speeds of over 430,000 miles per hour. At its closest, the probe came within 3.8 million miles of the sun's surface. To put that into perspective, imagine the sun as a basketball. The Parker Solar Probe would travel just 5 inches above its surface. It endured unimaginable heat and radiation to gather data about this outermost layer. One mystery it aims to solve is why the corona is much hotter than the sun's surface, reaching millions of degrees despite the photosphere below being only a few thousand. Understanding this helps us learn how the corona generates solar wind and drives space weather that affects Earth. Then below the corona lies the chromosphere, best seen in ultraviolet light. This layer is where short bursts of plasma, called spicules, shoot upward into the corona. The chromosphere acts as a bridge between the sun's surface and its outer atmosphere, fueling much of the corona's activity. These amazing images were captured by Simon Tang, known as the Stupid Astronomer on Instagram. Check out his profile for a closer look at the sun like you've never seen before. Images like this are truly spectacular and mesmerizing, but they still don't quite show the sun in visible light. To see the sun's surface in full detail and visible light, we have to go to Hawaii, home to the Daniel K. Inouye Solar Telescope on the island of Maui. This 4-meter telescope, the largest solar telescope in the world, came online in 2021 and has since given us a groundbreaking view of the sun's actual surface. For the first time, scientists could observe the intricate patterns and constant motion that drive the sun's incredible energy output. The sun's surface, or photosphere, is far from calm. It's a place of constant movement, where boiling plasma rises and falls in a process called convection. The sun's surface churns like a pot of bubbling soup, constantly shifting and swirling with energy. These movements create convection cells, massive patterns on the sun's surface. They last only a few minutes before new ones form. Imagine vast structures, each the size of the United States, forming and disappearing in just seconds. You can recreate a similar effect on a smaller scale at home, with a pot of hot oil mixed with glitter powder. A bit like a lava lamp, the hotter oil rises, cools, and sinks back down, creating a rolling, bubbling motion. It is quite satisfying to watch. And then there are these dark spots called sunspots. They appear darker because these regions are cooler areas on the sun's surface, where strong magnetic fields block the flow of heat from the sun's interior. Sunspots are not just surface features. They serve as indicators of the sun's magnetic activity. Sunspots follow an 11-year cycle of activity, peaking during what's called the solar maximum. During this time, the sun produces more sunspots, solar flares, and coronal mass ejections, creating an intense period of solar activity that scientists closely monitor. The sun's surface is always in motion. Studying these features helps scientists read the sun's changing activity, understand its behavior, and make predictions about future changes. But how long can this process, this endless churning and turning, keep going? What happens when the sun eventually runs out of fuel? How much time do we have left? And will life find a way to persist? To determine our sun's fate, we need to look at how other stars evolve based on their size and mass. Not all stars are created equal. Our sun is what's called a main sequence star. These are average-sized, yellow stars that burn steadily for billions of years. Others are smaller, cooler, and dimmer. These are the red dwarfs, burning through their fuel slowly and steadily for trillions of years. We tend to think of our star as this incredibly gigantic thing, but our sun is absolutely tiny compared to some of the giant stars in the sky. These are so massive that their existence is bright, brief, and explosive. The more massive a star, the faster it burns through its fuel, and the more dramatic its demise. These stars occupy the upper end of the Hertzsprung-Russell diagram, a map astronomers use to classify stars by their size, brightness, and temperature. Unlike stars like our Sun, which burn steadily for billions of years, these giants live fast and die young. When a giant star runs out of fuel, it doesn't fade quietly. Instead, it goes out with a bang in an event called a supernova. These explosions are some of the most powerful events in the universe, and they are crucial for the creation of life as we know it. But how does something so violent lead to something as intricate as life on Earth? Before supernova explosions, the universe was mostly hydrogen and helium, a simple primordial mix. Inside stars, heavier elements like carbon form gradually over time. And then when a giant star explodes in a supernova, it violently scatters these elements into space, seeding the cosmos with the materials needed for life. Without these explosive events, the building blocks of our existence would be missing. There would be no planets, no oceans, no life, no you. The universe would be filled with only hydrogen and helium, far too simple for complex life to exist. The calcium in your bones, the iron in your blood, all of these elements began in the core of a star and were spread across the universe by supernovae, scattering the gas and dust needed to then form new stars and planets. Think about this. Every atom in your body was once part of an exploding star. Or in Carl Sagan's words, you are star stuff. Every breath you take, every heartbeat, every molecule and every cell in your body carries the legacy of these cosmic explosions. But the same forces that create life also hold the potential to destroy it. The sun is not just a peaceful giver of life. It also has a more dangerous side, one that can threaten our modern world. One of these dangers comes from solar winds, a constant stream of charged particles coming from the sun. On regular days, these particles interact with Earth's magnetic field, creating the beautiful auroras visible near the polar regions, in places like Scandinavia in the north or Antarctica in the south. But sometimes, the sun releases immense bursts of plasma, known as coronal mass ejections. These violent eruptions hurl material from the sun's outer layers into interstellar space. Scientists are still working to understand what exactly triggers these massive eruptions, but their effects can shape our entire world. In 2012, Earth narrowly avoided a coronal mass ejection event that scientists think could have caused catastrophic damage to satellites and power grids. The last time Earth got directly hit by such a phenomenon was in 1859 during the Carrington Event. British astronomer Richard Carrington observed the solar flare that triggered it through his telescope in 1859. He sketched what he saw, capturing the dramatic moment when a massive burst of energy erupted from the sun. The event caused telegraph systems to fail and lit up auroras as far south as the Caribbean. If a similar event struck today, it could be devastating. Imagine waking up to find your GPS not working, the internet offline, and the power gone. Coronal mass ejections could bring the modern world to a standstill, causing chaos in our highly connected lives. And the scariest part? Such an event could strike any time and without much warning. From the time of detection, the ejected particles could take anywhere from 15 to 18 hours to reach Earth, sometimes less during particularly fast events. This means that while we may have some time to prepare, the window is short and the stakes are high.
The sun. This is pretty cool. It gave us a pretty hard smack yesterday. What are we talking about? A massive flare.
Following a series of intense flares that started over the weekend.
But a massive solar flare almost sent us back into the dark ages.
Researchers are working on early warning systems to better protect us. NASA's Sunrise mission, for example, is set to transform our understanding of coronal mass ejections. The project uses a fleet of 6 toaster-sized CubeSats working together as a virtual radio telescope to observe the sun's radio emissions. By watching these emissions in detail, scientists can track where charged particles in CMEs come from and how they move. This helps predict when and how these bursts might affect Earth. The mission brings us closer to understanding the sun and improving space weather forecasts to protect the technologies we depend on every day. Probes like Sunrise are our first line of defense against the unpredictable power of the sun. Yet, the sun's immense power shows just how fragile our modern world can be. What does the future hold for Earth under this powerful star? As the sun ages, how will it change our planet? What changes are coming, and how will they define the fate of our civilization on Earth? As the sun burns through its fuel, it will grow brighter and hotter. This gradual change will reshape Earth over millions of years. The ever so slightly increased brightness will speed up a natural process called silicate weathering. As the sun grows brighter and hotter, it will intensify Earth's water cycle, driving more evaporation and rainfall. Rainwater, carrying carbon dioxide, then reacts with rocks, pulling CO2 out of the atmosphere. This might sound counterintuitive since today we face a problem of too much CO2 in the atmosphere. But over millions of years, this natural process will strip the atmosphere of carbon dioxide. As CO2 levels drop, plants will begin to die. And Earth's ecosystems will slowly collapse. Then, in about 1 billion years, the oceans will start to evaporate, leaving Earth scorched and barren. And in 5 billion years, the sun will swell into a red giant. Consuming the inner planets, possibly also Earth. Our once vibrant planet will probably become one with the sun. This marks the last chapter of Earth's extraordinary story. Everything that was ever built, felt, or dreamed on Earth will return to the simplest of forms, swallowed by the sun itself, ending its story as part of a dying star. In a way, it's a poetic return to our origins, life and matter, completing an endless cycle. The sun has been the force behind everything we know. From the first spark of life to our modern world, its energy has shaped our human existence. While the future holds impossible challenges, Humanity's ingenuity has always allowed us to adapt and thrive. But what if the same process that will one day end life on Earth could help save it today? Silicate weathering, a process that slowly removes CO2 from the atmosphere, is being studied as a potential tool to fight the climate crisis.
Enhanced weathering is the acceleration of natural rock weathering. As the rock weathers, it captures carbon and locks it in for thousands of years, and it can be used and accelerated for use on a global scale.
Researchers spread crushed silicate rocks to see how they interact with the environment to absorb carbon dioxide. This natural process usually takes millions of years, but the trial is testing if it can be made more effective for modern use.
The crushed basalt we spread is 0 to 4 millimeters. By increasing the rock's surface area, carbon dioxide is captured approximately 50,000 times faster than in the natural world. Carbon dioxide is the greenhouse gas that we need to get out of the atmosphere. And during the natural biological cycle, the carbon dioxide ends up in the soil, and the basalt captures it, turns it into bicarbonate ions, and these are washed out to sea. We're taking it from the biological cycle into the geological cycle, and this is what we're excited about.
The findings will help determine whether this method can be expanded to remove carbon emissions from the atmosphere on a global scale. The sun also fuels innovation, from solar energy to advanced research into space weather. These efforts help protect Earth from the sun's destructive power, while harnessing its energy to build a cleaner future. Our ability to adapt and innovate shows how resilient we are as a species, even as we face the challenges of our aging sun. In the grand story of the universe, humanity is just a blink. But in that short moment, we've harnessed the energy of a star to shape our world and reach for the beyond. The sun, this immense nuclear reactor in the sky, has fueled life and shaped the story of our planet. The good news is that it won't go supernova, and it looks different in visible light than you probably thought. It's the source of every spark of life you've ever known, and the force that will one day bring it all to a slow but dramatic end. Humans have been telling stories about the end of the world for millennia, but it is thanks to science that we now understand how this planet will truly meet its end. Will humanity still be here to witness it? Perhaps we'll have risen beyond our divisions and are on our way to other stars. Or perhaps we'll be long gone. For as long as we've been around, humans across cultures have looked for something bigger than ourselves. Something powerful, something that connects us to the universe. And maybe that something has been with us all along. The sun. Think about it. The sun gives us life. It grows our food, drives our weather, and even powers our bodies. Every bit of energy we use today, from the plants we eat to the fuels we burn, started with sunlight. Without it, there's no us. It creates. It destroys. It's been with us since the beginning, and it'll outlast us all. In a way, it reflects the traits cultures across the planet often associate with a god. And like all great gods, the sun doesn't just give. It takes too. One day, billions of years from now, it will grow so massive that it will swallow everything we know. Earth, the planets, even itself. But that's not the end of the story. its energy will scatter across the universe, fueling new stars, new worlds, and maybe even new life. That's what makes the sun so incredible. It's more than a giant ball of gas. It's a reminder that we're part of something much bigger, something ancient, something eternal. So, the next time you feel its warmth on your skin, take a moment. Think about everything it's done for you, for all of us. The sun isn't just a star. It's the reason we're here. This is your brief moment under the sun. Let's make it count. Not just for us, but for all the generations yet to come. And while we marvel at the sun's power, there's another untapped energy source closer to home. Deep beneath our feet, there is an ancient power that scientists are now learning to harness. How can drilling into the heart of a volcano unlock clean, sustainable energy? And what challenges stand in the way? Could it result in disaster? Let's journey into the depths of the earth to find out. If you found this fascinating, please consider subscribing.